Today's workshop, so this first workshop, is called Design Tools and AI for Facade Design. So already I was very happy when I had the chance to moderate this workshop. Very interesting.
So our topic is the design and analysis of glass facade elements using AI. Since many years, we have freely accessible online tools for our clients, and not only for our clients, so they are available for everybody. Important for us is that you can analyze different glass structures and that it's easy and very clear to use. So these applications are, let's say, non-expert tool. And when it comes to more complex calculations, or let's say if it's a Façade supported window and not just a beam situation, you can also choose between a linear and non-linear calculation approach, which is quite important for optimization of the glazing construction, that you can really downgrade the glazing thickness to the minimum.
And I want to have a photorealistic representation of that glass structures. In the best end, I end up with a plan, with a detail. So that would be, I think, an ideal that I just prompt. I think there is a lot of potential in that, but don't believe that that comes for no cost, especially for the technical applications in mechanical engineering and civil engineering and architecture. So we always have to bring in our expertise and how we did that. So whenever you have that kind of data, like a description of the problem and a human label or a computational label, then that's called supervised learning, and you can do regression and classification. And if you remember your studies, everyone, I think, at least in engineering, did some regression, so you're already machine learning experts. The algorithm would not tell you the content. The algorithm will just tell you, hey, these 5 plans look similar, but you as a human have to interpret if that's a facade detail or something else. One really big thing to keep in mind if you want to implement AI into your business is always check these 3 things. Do I have data? If there's no data, no AI. Does the data contain the pattern which I want to model? For example, I want to design a facade. So if I have weather data, maybe they're not totally fit to do a structural analysis. So the first thing is always to deal with the data. Believe me, you don't spend a lot of time in the modeling, in neural network training, whatever. You spend 80% of project time in creating the data, looking at the data, discussing with experts.
Yeah, and let's say, okay, we are talking about sound prediction. Let's take a sound control monolayer from Cover and another 4mm glass. So this is, I think, quite simple. And now let's say predict. And now you can see the estimated values. So it's an RW value of 37.2 dB.
We also want to establish trust by providing the test report if there is any. So you can double check all predictions against the ground truth. Just to give you an idea what the machine learning model in the end or in the back end is, that was found to be a random forest regressor. Random forest is a simple concept. You say, I have several models which are fitted to the database, and in the end, I take a rule out of all predictions and then come up with some final prediction. But I think the most important thing for the practice is that we do our science, we do that in the back, and we provide a very nice user interface. And Ingo showed it, and I hope you agree that is really user-friendly.
So we decided to develop also another tool, our Strengths Lab. Okay, so this is the Strengths Lab AI. Again, you can choose the right language. You can switch between imperial and metric units. You can enter your project name, let's say Venice, and you can give also some notes here. And let's do a simple calculation today for, let's say, a balustrade.
We find or have to find a balance between I have a good machine learning surrogate, meaning it does a prediction of the theory well, like, okay, it predicts 400 megapascals, but as we know that nobody is allowed to design that, maybe we don't have to be that accurate in that region. So we allow an error of maybe 5 or 10%. That motivated us to formulate a specific loss function for neural network training. So as I said, that was the first, I would say, civil engineering point of view. So let's do 3 experts because of the numerical ranges. And the other was we have to come up with our own neural network architecture, also because of the numerical ranges and what we want to achieve with the different qualities. As I said, the most important thing here is we do our science, we give that to experts, they should review it, but for the user, it should be easy and light to understand interface.
So this is then the application, the name will be Carbon Reduce AI. So just to give you an outlook.
As you see here, we stick to the layout, user-centric simplicity. I think for me, the most nice thing is that we have these connections between all the tools. And so that's it. Thank you for that.
Thank you very much.